Well, if you recall the previous discussions in this class, we have mainly discussed three themes. We have first understood what is the place for engineering in our whole discussion. Second, we have tried to contextualize the subject engineering design. And thirdly, we have seen what is the design process which is common in engineering design. These three themes have been dealt in my previous three lectures. If you recall the last lecture wherein the elaboration on the process of engineering design was done, you will recall that the first step in engineering design after doing the market study is to come out with requirements, basically saying what needs to be done. A clear, definite problem statement is a starting point for solving any problem. Writing a very clear, no-nonsense specification. In my today's lecture, I want to deal more on how and what of product design specification, or PDS as it is called as. The question is very simple. How do you comprehensively and completely capture all the complex issues involved in designing a new product? Designing a new product is not simple. It's a very complex phenomenon. If you don't understand what to do, the final product will be a big disaster, a failure. How to understand what people want is what we'll see today. To start the discussion, let us take something very simple and then build a solid theory. Imagine that you want to buy something. What? Say a pair of jeans. How will you start? You want to buy a pair of jeans. You go out. Basically, you have only two options. Either you go out and buy a pair of jeans, or if you are a guy like me who don't get specified size according to the market specifications, go curse all the jeans manufacturers for thinking that if you have this much waist, you should have this much length. Curse them for making all such jeans. Pick up which fits okay kind of thing. Come back, give it to the tailor, cut it to half, and feel sorry that the left part can be a 3/4 which you can use. Anyway, so basically we have only two choices. One is to go out and buy and use it. Other is go out, buy and alter and use. In a more drastic case, we don't have that choice in jeans today, but females definitely have a choice. Of course, guys also have a choice. If you want, you can buy the raw material, give it to your tailor and stitch it according to the specification. We will not discuss all that. But basically, consider the case of you going out to a market and buying a pair of jeans. What will be that thing which you will look for? Did I hear brand? Why brand? Most of the answers will be found if you take a brand. All the questions on quality, all the questions on durability, usability, all these things need not be asked. Because brands have already created a trust factor. You are not going and buying a jeans, but you are buying on the basis of the trust. Keep it separate, what else? I don't want branded, then what? Okay, next. Design. In a jeans, are there designs in jeans? I don't know, I am illiterate, sorry. Price, okay. Color. That's again a very new thing to me. Are there colors in jeans? I know only two. But denims always comes either in blue or in black for me. Fine. What next? shade, okay. Then what? So let us say the summary of the discussion is this, that you already know what you want, that you say I want this color, this fit, this quality, whatever you mean by quality, this price, everything is fixed. Now my question is, then shouldn't shopping be a 1-minute job? Go, give your specification, take the jeans, come back. Then why do especially girls spend half a day piling up loads of materials and finally say thank you and come out? Specification keeps changing, is it? You look this, you look that, oh, this is better than that. Every next item you see will always be better. Something on the rack will still be better than what is there on. This is very dangerous trend in engineering. Imagine what would happen if we build the buildings according to how girls select their clothes. No, so just a comparison. You start building, after you build first floor over, start building second, say no, this room should come here. Demolish that, build it here. Again, demolish that, build it here. Unless and until you are in Ramaya, this thing can't work. This can work only in Ramaya. Build half, demolish, again build. This can happen only here. No one else can take such drastic steps. Anyway, so the point is very simple, that you already have a list of specification, then you go around searching for it. This is a very logical way of doing it. In life, anyway, I'll not go through all the sub stories. Well, can we follow this process in engineering design is a question. Of course, the answer is yes. As I keep saying, engineering design is nothing but common sense. So, in order to solve any problem, what is the first thing that you have to do? You have to identify the specification, the requirements, what the system should do. If you know that, everything becomes clear. In the textbook, he gives all sort of nonsense examples. Ken Hurst's book. I am not particularly interested in taking up that cases. For example, if you have read first chapter, when dealing with the history of engineering design, he takes the example of a hand pump and tries to claim that hand pump was an idea even in 8th century, then it improved in 13th century, 19th century and all that. I am not interested in taking up his cases. As a case of how engineering design is a complex topic, he takes the example of ABS. Well, I am not going to take the same examples, please understand. In this particular context, he takes the example of a, bottle opener, corkscrew and all that. I am not interested in that. I will take my own example. What? Okay. Say we want to design a coffee cup. That's a good example. A coffee cup, a simple, humble coffee cup. I want to design a coffee cup. Tell me your expectations. How do you want the coffee cup to be? I am a designer. I am asking you how the coffee cup should be. It should be cylindrical. Why? No, there should be a reason given. How should a coffee cup be? How? Please note, I have deliberately used the term coffee cup. I have not used the term coffee mug. I have deliberately used the term coffee cup. The choices are many. Starting from what you get today mostly on railways, if you go to North India, the earthen cups with a particular shape, to steel cups we use in South India, to all the Chinese cups, which I hate to the core, the porcelain cups, to what we get in the coffee shops. Various categories. Now, keep all this thing in mind and tell me what do you expect from that very good coffee cup. I mean, incidentally, is there any difference between a coffee cup and a tea cup? Or a Complan cup, Bonvita cup, Horlicks cup? Interesting question. Is there a difference between a coffee cup and a tea cup? There is. Well, if you have even the basic knowledge of Chinese way of living, they take their tea drinking very seriously. Have you seen all these Chinese cups? Do you know why they drink? Okay, incidentally, one of the trivia is that the word chai is derived from Chinese word cha. Incidentally, cha is a word used to refer tea in most of Indian languages. In fact, in my mother tongue Tulu also, we use the word cha for tea, which incidentally is the Chinese word. They started drinking tea, and for them drinking tea is a big ritual. You don't drink tea simply like that. One small cup of tea, they will take hours together. That is why if you see the Chinese cups, the handle will be, so very small, where you can't insert your finger. You have to take it like this. The reason is that they will have only small sips of tea. And pouring tea is a very great ritual there. You can't just pour the tea. If you are pouring tea, if a younger guy is pouring tea to an elderly person, that means he is submitting himself. He is confessing something or things like that. There's a whole lot of ritual. Anyway, come back to engineering design. Let us give the specification for an ideal coffee cup or a tea cup. How should it be? Yes, shape. It should have a handle. Compulsory. South Indian coffee steel tumblers do not have handles. Correct? No, I'm not complaining. I'm just saying. Is it mandatory for a coffee cup to have a handle? Okay, go next. What? Exactly. One of the most important thing, it should be resistant. Or can you reframe the whole statement in different way? It should be heat resistant. It should retain the heat. It should be insulated. A perfect coffee cup for us should not be open. If it is open, all the heat will go up. No. A true coffee lover will never like that. So our futuristic ideal coffee cup should be insulated in such a way that it retains all the heat, so that the coffee is served piping hot and all that. Anything else you want to add? Well, you have not yet started. Okay. What things come to your mind when you say coffee cup? You should have a handle. You should save that. Or what next? It should not be very bulky. You should hold it, right? What next? You should have a pleasant appearance, aesthetic to look at. What next? You should not break. I'm talking about ideal. What's wrong? All this porcelain and other things, if I drop, it will break. I don't want my coffee mug to break. What next? Oh, I'm giving all the specification. Nothing. Okay. Fine. Remember one thing. Any engineering designer, you know what's the biggest problem he faces in his life? It's this. Any engineer, when he wants to do something, wants to hear from the other side. Imagine this being a engineer-client conversation. You want your client to be very specific, but your clients will never be specific. To understand what they want without they telling it is the biggest challenge. No client will come to an engineer and say, I want a house in 30-40 with the bedroom which has this much length, this much height, this much beam should be of this weight, the pillar should be of this much strength. Nobody will tell that. What will they say? Or an automobile engineer. They will never say my engine speed should be this much and all those technical specifications. They will speak of their dreams. In real world, nobody gives specification. They always talk about their dreams. The biggest challenge before an engineer is to convince his clients that all the dreams that he is having cannot be realized. To puncture that dream is the biggest challenge before an engineer. That is more so in software for us. At least building they can see and tell, right? In software they can't see. You can't see software. They'll come and tell you, I want my software to be very user friendly. I want my software to be good. How do you interpret that? The fitness of a pillar can be tested. The car can be tested. You can crash test a car for safety. What can you do for a software? It's very difficult for us. Our life is so difficult. Okay? So, what is happening here in the class, I am saying, is the biggest problem. That we can't exactly say what is there in our mind. That is the reason why you have to do this exercise again and again to understand the real meaning of how to write the specification. Today morning I was doing an exercise with the pre-final year students, asking them to write the specification for the project that they are doing. They can't. Believe me, even a 10-year experienced guy can't write it perfectly. It's one of the biggest challenges for us. But anyway, I'm just introducing you to the ideas. So, the essential components of product design specifications are: the first category of requirements, we call it performance requirement. Any system if you want to develop, when you start giving the specification, this is what I want, you start with performance related aspects. For example, take the coffee mug. How did we start? How should it work, right? That's how we start, the performance related aspects. That is the first thing that you have to write. This will cover many things. For example, this will cover the functions. I have a favorite discussion which I have, a long discussion anyway, I'll just shorten it. Usually, functions come in two different categories. One is what I call functional, another is non-functional. Functional is something you can see. Non-functional is something you can always feel, but you can't see. There is something unique about every product. We feel it. For example, when I wear a pair of jeans, I know whether it's good or not. I know it. Right? When I drive a car, I know inherently whether this machine is good for me or not. I can't tell it why. This nameless quality which is inherently there in every product, that is what I call as non-functional requirement. Take a house. A house may be well planned, but sometimes when you enter into a house, you will feel that. There will be something in some spaces which you feel. It is inherently there in every engineering design. So functions always come in two flavors, functional and non-functional. Okay? Functionals are very specific. Non-functionals are something which we always feel. Ergonomic factors is the name generally in the engineering terminology. We use it to refer to any human related aspects. Have you seen at least the picture or video of a cockpit of an aeroplane? How many switches? How many displays? Too many. See a satellite control center? Sometimes they have to climb a ladder to switch on something. Right? It is often understood that there is a way to organize all these things. You can't randomly arrange everything. In engineering, we give a lot of emphasis on how human related factors should be taken into consideration. For example, somebody who is building this building should take care about lighting, the flow of air and everything. It plays a very important role. All these things are combinedly called as ergonomic factors. Okay? Add to it, there are many other components. I can make a long list. For example, weight, many physical factors, weight, appearance, aesthetics, all these are performance related things. So whenever you are defining something, the first thing that you have to do is to find out what is the performance related requirements. What are the requirements regarding these? Fine? Okay. The next category of requirements are manufacturing requirements. This is what the final product should be. But how will you make it? For example, our coffee cup. We have said many things. How will you manufacture? You have to select a material to meet your requirements. It should be insular. So what is the material you are using? Right? That is how you should think. What is the process? What is the quantity required? When is the date of delivery? All these things matter. Because say coffee cups. If I have an order for 10 coffee cups, I can call a, what is it called? Kumbaranige ಏನು ಹೇಳೋದು ಕನ್ನಡದಲ್ಲಿ? English. Potter. I can call a potter, ask him to do 10 cups, handmade, nice, with all the materials, I can do it. But if my requirement is 10,000 cups, I should go for automated manufacturing. So, various issues that you should worry here are, what is the material to do such products? What is the process? What is the assembly? Assembly in the sense, will you get some parts from somewhere and then just simply fix it? Or will you make all the subcomponents and in a assembly line will you manufacture the whole thing? All these kinds of issues, right? Quantity. Packaging is very interesting. Imagine again coffee cups. If I make my coffee cups using porcelain, then packaging should be in sync with what it requires, it demands, right? All those issues. There are many issues. If we meditate, we'll get so many new ideas on what to include, what not to include. Please remember, this is not a cookbook that I am giving you, which will simply follow. Just a broad outline. Meditate on this, you will get more ideas. Due to time constraints, I am hurrying up, that's all. Next requirements are quality standards, or what Ken Hurst calls as acceptance standards. For example, when one starts to build a building, an engineer simply doesn't start with the foundation. What should he do? What should he do? He should do the soil testing. He will first do the soil testing. Then he will see whether the region is within the seismic. He will take all the seismic information and see whether it comes in the danger zone. And he should follow all the building codes. There are different building codes which he should follow. Meaning, in any mature engineering profession, there are some accepted standards. Those standards come because people have practiced the art from a long time. They have codified what is the best way of doing this. We have to follow it. This is what is professional intelligence. Okay? What are the things that we should see here? First is testing. Testing is one of the important ideas in engineering. Anything we do, we actually test it. Test it to meet our performance requirements. There are many kinds of testing. We'll see all those things later. Destructive, non-destructive, intrusive, non-intrusive kind of ideas. Second, inspection. During manufacturing, it's a normal process. See, you can't test each item. Can you test each item? Impossible. Therefore, what do we do? There are two approaches. One is take few samples from the manufactured products, then test it. One. What is the second? What is the second way? Guarantee a process which is of right quality. If the process is right, the product will be right. Inspection is mainly dealing with whether you are following standard processes or not. If you build a building, either you wait till the building is complete, then put some 10,000 kg rock on it and see whether building is safe or not. That is one way. Stupid way of doing things. Other way of doing things is, while the building is being built, come and inspect whether they are following all standard procedures. Correct? So these two things are there, or blindly follow accepted standards if it is available. Okay? So these requirements have to be followed. Next set of requirements are operational requirements. Andre, once the product is ready, next what? Once the product is ready, how should it be installed? What are the prerequisites? How should it be used? And how should it be maintained? And fourth, very importantly, what are the safety requirements? For example, coffee cup, let us say. If I use some special metal alloy in making the coffee cup, which preserves heat and all that, maybe I cannot keep it just like that. I may have to keep it in a special refrigerator in a particular temperature. Maybe, I don't know. Futuristic machine, liquid nitrogen or something like that. I don't know. How should you use it? Maybe that particular coffee mug is so futuristic that you can't hold it with your hand. You have to have a special glove or whatever to use it, because it uses that special metal or whatever. What should we do if the handle breaks down? There should be a maintenance formula for all that. There should be some safety norms. Any product cannot be used for every purpose. There will be a safety norm. For example, this fan. It does not run just like that. It needs a regulated power supply. Our coffee mug should hold hot coffee. Yes, that is a requirement. But how hot? Can you give me a 400 degrees Celsius coffee, just pour into it and hope that the coffee mug does not break? No, it's not possible. So what are the safety requirements? Right? All these things are important. Okay, so we are making a comprehensive list, but we are very sure that we will fall short. A very special list of requirements for specific products are disposal requirements. I believe in the principle of equality. Certain, for example, take ships. Ships. After you build the ship, after you commission the ship, after it passes the entire life in the sea, you have to decommission the ship. Right? What is the process next? You have to dismantle the ship. You can't just leave it like that. Do you remember that case which happened wherein France was sending some ships to Gujarat? Gujarat is very famous for dismantling of ships. Remember, it's a very dangerous thing to do, because so many metals which will cause even some radioactive things and stuff like that will be involved in building a ship. So while they dismantle the ship, what about safety of the workers who are doing this is a very, very complex issue. That issue is there even with computers and in cell phones. When we just throw away our computer or cell phone, do we even for a moment worry what happens next? Like paper, computers and cell phones cannot be recycled. Because what is the metal used? Main metal used, important metal used, which is very, very dangerous? Silica. Silica, which is very dangerous. So, in some products, there should be requirements on how will you dispose the product. There are legal, disposal. Sometimes there is a strict law on how should you get rid of this product. Environmental hazards, how to take care about all that, stuff like that. Or company may have its own policy on how to deal with such issues. Being very socially responsible and stuff like that, companies can come up with their own standards for maintaining this. Whatever it is, the final point is this. No way am I claiming that I have listed out everything. Nor is it possible for anyone to do this. Every product, every specification is a new journey. We should start afresh. Especially in software, the whole picture changes dramatically when you are writing the specification for a software. Let me tell you 2 or 3 things before I wind up this session. One, product design specification forms the first step in doing anything in engineering design. So if you fault here, don't expect your product to be good. Second, writing PDS is not one-time job. It is an evolving, continuous process. You write the requirements, start doing things, find that they are incomplete, again come back, update this. It's an iterative, continuous, repeated process. That's the second point. Third point, product design specification cannot be written unless you have understood the market conditions clearly, which we have not discussed. If you have not done the market survey, you can't write this. That I assume you will learn on your own. Fourth, PDS is not a simple document. It has a very strong legal value. This is a promissory note you are giving to your client. This establishes the relation between you as a professional and the client. Meaning, if you don't deliver any of the things you write in PDS, he can pull you to court and seek damages. So, bottom line, be very, very careful when you write PDS. Use legal language. Legal language, scientific language means no direct speech, no personal reference, first person reference. I promise that this system will do Allah. The system shall provide. That is the language to be used. Indirect third person reference, not direct first person reference. This is the language specification. I close the lecture here.